Hello, AP Statistics students, and welcome to the College Board virtual instruction for AP Statistics. It is Monday, April 13, and my name is Luke Wilcox. I am an AP Statistics teacher at East Kentwood High School in Kentwood, Michigan. And listen, I hope you've been looking forward to today's lesson because today is the day where we go all the way back to the first week of AP Statistics, to some stuff that's very likely going to be pretty easy for you, but stuff you haven't thought about in a very, very long time. So I'm hoping to give you some important reminders today from some of the material that you learned very early on in the course. So let's go ahead and jump right in. First things first, let's make sure that we are all in the correct spot here. This is AP Statistics. As I mentioned already, my name is Luke Wilcox from Kentwood, Michigan. And I'm going to give you a couple of reminders here up front. And listen, if you've been with us for the last couple of weeks, you probably already know this, but we very well might have some new people with us today because we are doing our review all the way back to the beginning of the year. So hopefully you know that we meet every day, Monday through Friday at 2 o'clock Eastern time. We are in the full AP exam review mode at this point, and starting today, April 13, we are going all the way back to Unit 1 in the CED, all the way through Units 5, and that will take us up through May 1st. So that is the next 3 weeks of review here will take us Units 1 through 5. And we are preparing ultimately for the May 22nd AP Statistics exam. Now, any of the resources that you might need for the lessons, which includes the actual lessons themselves, as well as the homework problems, you can find at statsmedic.com/YouTube. All of the lessons are organized there by date, so you would just look for April 13 for today, and you'll have access to a PDF of the lesson as well as the homework problem from today. And the final announcement here is for any student who does not have a device or internet access to be able to take that AP exam on May 22nd, can request access to those from the College Board at cb.org/tech. So if you or someone else that you know is in need of a device or internet service, please give them that address so that they can make that request. I do know that the College Board is very, very committed to making sure that every student has access to take the AP exam on May 22nd. Okay, so I'm going to jump back to the homework problem, which actually I assigned you on Friday. On Friday, we talked about type 1 errors, type 2 errors, and power. And this is an example question of something that you might have to think about on the AP exam here. So let's just jump right in and see how well you did. So here's what the question says. A one-sided hypothesis test is to be performed with a significance level of 0.05. So I'm going to pause right there and recognize the fact that we are given the alpha level, the significance level of 0.05. Suppose that the null hypothesis is false. Okay, this is important. If the null hypothesis is false, I'm going to say that another way. That has to mean that the alternative hypothesis is true. And that's probably going to be something that we'll need to know to answer the question. So if the significance level of 0.01 were used instead of a significance level of 0.05, which of the following would be true? So it appears to me that the question is saying, what would happen if we were to decrease the alpha level there? Now, I'm going to remind you of a couple of things from the lesson on Friday. First is just a quick overview of the type 1 error, type 2 error, and power. And I think the best way to organize this, we had a little bit of a chart that we looked at on Friday. And in this chart, on the top, we knew that either the null hypothesis was true or the alternative hypothesis is true. And because we were given in this problem that the alternative hypothesis is true, that's sort of a hint to me that I'm going to be looking at this column within this particular table. Now, the other thing that goes over here is our decision from the significance test. And we know there are two possible decisions. Either we reject the null hypothesis or we fail to reject the null hypothesis. Now, if you recall from Friday, this top left here is what's called a type 1 error. That's when the null is true, but we reject the null. The one below that doesn't have a fancy name, but I like to give it a smiley face because it is a good decision there. And then on the right-hand column there, when the null hypothesis is true and we reject the null hypothesis, well, that's a good decision. And in fact, we call that the power of the significance test. And then bottom right, this is another one of the errors, but this is what's called a type 2 error. And listen, by the setup of this problem, because the alternative is true, we know that we're going to be dealing with this part of the chart here. And one thing to remember from Friday is that power and type 2, the probability of a type 2 error, are related to each other, because those are the only two possibilities, which means that those two probabilities have to add up to 1. So the way we wrote that on Friday was we said that the probability of a type 2 error plus the power has to equal 1, because those are the only two possibilities here. Now, one of the other big things that we talked about on Friday was how to increase the power of a significance test. And we mentioned 3 different ways that you could increase the power. So let's make a quick note of these here. Number 1, probably the easiest and makes the most sense. If we're trying to increase the power, which is a good decision from our significance test, it certainly makes sense that if we had a bigger sample size, that would probably help. So we could increase n. Now, one of the other things that we found on Friday was that if you increase alpha, that will also increase the power, because it increases the probability of rejecting the null hypothesis, correctly rejecting the null. And then the third one had to do with the distance between the null hypothesis and the alternative. And if you make that distance greater, then your power is also going to go up. Now, very clearly here, this is the one that matters in this particular multiple choice question. But we have to recognize that we're going in the opposite direction here, right? That the alpha value is actually going down. Well, that means that the power has to be going down, right? Decrease alpha, decrease the power. But here's the other thing. If you look at this equation, if the power is going down and this equation has to add up to 1, doesn't that mean that the probability of the type 2 error would have to go up? And so when you look at our answer choices here, they're all about type 1 error and power, and we need the one that says that the type 2 error is going up and the power is going down, which I believe to be answer choice E. The type 1 error would increase, the power of the test would decrease. So the correct answer here is E. So I hope you did okay with that now, and you are ready to jump into the new lesson for today. And so I'd like to start with my lesson overview. But listen, I started thinking about planning this lesson, and I had to go way, way back to the very beginning of the school year. And actually, I found this picture from the very first day of school, 2019-2020. And the reason why I'm showing you this picture here is I'm going to make the argument that there has been quite a bit of time that has elapsed since that first day of school. People might even look a little bit different than they did at the beginning of school. There's a lot of things that have happened in the world since the first day of school. And so this is the reason why I think today's lesson is so important, is that we have to go all the way back to August or September of 2019, and there's very likely some things that you have forgotten since then. So here's where I'm going to take you in today's lesson. The learning targets. First one, describe and compare distributions of quantitative variables for 1 or 2 groups. Learning target number 2, compare the distribution for a categorical variable for 2 groups. So we're going to be dealing with both quantitative and categorical variables in today's lesson. And then the last learning target is use graphs to decide if there's an association between 2 categorical variables. And I am also in today's lesson going to try and make some connections to stuff that you did way, way later in the course, dealing with inference, specifically significance tests. So let's go ahead and jump right in. All right, here we go. Now, today's question that we're trying to answer, the context for today's lesson, is about which AP class has a higher GPA. And we've got this classic battle between AP Calculus and what we all know to be superior AP Statistics. So here's what the problem says. A university admissions officer wonders if grade point average differs between AP Calculus and AP Statistics students. To find out, she selects a random sample of 20 AP Calculus and 10 AP Statistics students. Here are the results for the 20 AP Calculus students. And it looks to me like we're given a dot plot of the results, as well as some summary statistics there. Now, here's the first thing that we want to recognize here, is the variable that is being measured by this data. And very clearly, the variable that we're measuring here is GPA. GPA is our variable. And the next question I want to consider is whether that is a quantitative or a categorical variable. Well, because a student's answer to this question is a number, that's a good hint to us that this is in fact a quantitative variable. Another way of thinking of that is a variable where it actually makes sense to calculate an average or a mean. And certainly we could calculate an average GPA or a mean GPA. So we know for sure that the variable that we're measuring here is a quantitative variable. So everything that we do on this page is going to be dealing with an analysis of quantitative data. All right, so let's jump right into question number 1 here, which says describe the shape of the distribution. And we have a couple of choices when it comes to shape. I think the first thing to always address is whether it appears that the distribution is symmetric or skewed one way. And certainly this is not a symmetric distribution, and it does have a skew to it. In fact, it looks like it's definitely skewed a little bit to the left there. Okay, so I'm going to say that this is skewed left. And I usually like to give a word out in front of that, like slightly, moderately. This is a fairly strongly skewed left distribution. So I'm going to say strongly skewed left. Now here's where I'm going to pause. I'm actually going to give you a very important AP exam tip. And that is when you're answering free response questions, you want to do your best to always include the context of the question. And so if you just looked at our answer right now, strongly skewed left, it doesn't say anything about the context of the problem here. And so I'm going to add in something here. I'm going to say the distribution of GPA is strongly skewed to the left. So now here very clearly I've included the context of the problem. Just make a little note here. What I'm doing is I'm including context. And on the AP exam, in a particular question, in one FRQ, if you've established context once, you don't have to continue to say it over and over and over again. So it's very good to do that right off the bat. So question number 1, we've taken care of the context here. All right, question number 2, is the mean or the median a better measure of center of the distribution? Well, the answer to this question depends on the shape of the distribution, and we know that this is a strongly skewed distribution. So the issue with a skewed distribution is that if you have a skew with possible outliers, like say this value down here, it's going to have a very strong impact on the mean. It's going to drag the mean way down, whereas the median is going to be a bit more resistant to that change. So in this particular case, the median is going to be the better choice for the measure of center for this distribution. And to give my explanation, let's talk about the fact that the mean is non-resistant. And I'm going to say non-resistant to skew and outliers. In other words, those outliers on the left, that skew to the left, that's going to draw the mean down quite a bit because it is non-resistant. Whereas the median is much more resistant. So even with that outlier in there, the median is not going to change too much. So because the median is resistant, that's the better choice, and that has to do with the shape of the distribution. So I'm going to say because the distribution is skewed left, we're going to go ahead and use the median as our measure of center here. And you can actually get that right from the summary statistics. The median is 3.9. So we're calling 3.9 the center of the distribution here. And you'll notice if you look at 3.9, it is not the center of the x-axis there, right? It's just what we're calling the center of the distribution of the values, because the median, the middle value, lies within that stack of dots. Okay, let's move to question 3, which is asking for the most appropriate measure of the variability or the spread of the distribution. And we actually have 3 pretty good choices of things that we could use for variability. The simplest would be range. We could also use standard deviation. We could also use IQR. And the answer to which one is most appropriate, once again, has to do with the shape of the distribution. We have a skewed distribution. And the problem with the skewed distribution is that the standard deviation is just like the mean in the fact that it is non-resistant to skew or outliers. What that means is that the outlier is going to have a big effect on the standard deviation, likely increasing the standard deviation quite a bit, right? Increasing that typical distance from the mean. Whereas the IQR, which is actually calculated using the median of the first half of the data and the median of the second half of the data, is much more resistant to change. Less affected by that skew and that outlier there. So almost with the same reasoning as above here, it's based on the shape of the distribution. So we're going to say, because the distribution is skewed left, we're going to use the IQR. Now we should go ahead and actually calculate the IQR here, which is the third quartile minus the first quartile. And if you look up above, we know that, let's see, Q3 is 4, Q1 is 3.7, and that's going to give me an IQR of 0.3. So that leads us into question number 4, are there any outliers? Well, certainly this 3.1 down here, GPA, looks like an outlier, but we want to actually test that using the outlier rule. So here's what the outlier rule says. If you are looking for an outlier on the low end, which I call a low outlier, which we think we might have here, in order for it to be a low outlier, it has to be less than Q1 minus 1.5 times the IQR. So we're going to have to do a little calculation here. Q1, we know from our summary statistics there, is 3.7, minus 1.5 times the IQR, which we already figured out is 0.3, and that number is 3.25. Now that 3.25 is giving us the cutoff value, and it's saying that anything lower than 3.25 here would be considered an outlier. So sure enough, that GPA of 3.1 is an outlier. Okay, so I'm going to say 3.1 is an outlier here. Now we should check on the other end. I really kind of doubt that there's a high outlier here, but just to go through the motions here and see what the formula looks like. In order for us to have an outlier on the other end, on the high end, it has to be greater than Q3 plus 1.5 IQR. So our Q3 here is 4, plus 1.5 times the IQR is going to give us a value of 4.45. Very clearly, there are no numbers that are greater than 4.45, so we certainly do not have a high outlier. We are left with just the low outlier of 3.1. Now, I'm going to pause right here and make note of something. These 4 questions are highlighting 4 of the most important features when you are describing a distribution, okay? So this idea of describing a distribution, if you're given a free response question that says something like that, you want to make sure that you address all 4 of the things that you see here. So let's make note of them. In number 1, we talked about the shape of the distribution. In number 2, we talked about the center of the distribution. In number 3, we talked about the variability or the spread of the distribution. And in number 4, we tried to see if there were any outliers. So those are the 4 things you want to make sure that you address when you are asked to describe a distribution. Now, one way that you can remember that, if you look at the first letters of all 4 of these, and you do a little bit of rearranging here, the acronym to remember is SOX, which stands for shape, outliers, center, and spread. And then I also like to add on the fact that you better include context, because that's very likely going to be part of the rubric on the AP exam. So SOX plus context is the acronym that we use to remember what features we have to describe for a distribution of quantitative data. All right, we're ready to move to the next part now, which says, here is a side-by-side box plot of the results from both samples. Okay, now not only do we have the results for the AP Calculus students, but now we also have the results for the AP Statistics students. And we are now given a box plot instead of a dot plot, along with all of the summary statistics as well. And it sure looks to me like these summary statistics are the same as what we see at the top of the page. But now we have the same values for the AP Statistics students. Okay, so number 5 says compare the distributions. Okay, very important here. We just talked about describing a distribution. You want to talk about exactly the same things when you are asked to compare distributions. So this whole idea of SOCS plus context, that's exactly what we need to address here when we are comparing the two distributions. So I'm going to make it very, very clear in my answer here that I'm addressing all 4 of them. And we're going to start with the shape. Okay, well, we already know about the shape for the AP Calculus students. So let's just state that again. And once again, I'm going to get context out of the way right at the beginning here. The distribution of GPA for AP Calc is, and we said strongly skewed left. But now we need to compare that to the shape of the distribution for AP Statistics. Well, AP Statistics looks to be a bit more symmetric there, right? There's not a big long draw on one side or the other. So I think I'd be comfortable saying fairly symmetric. Now, we don't know exactly what's happening within each one of these quartiles. There could be some peaks and valleys within each one of these quartiles. But sort of generally speaking, this box plot to me is saying fairly symmetric. So I'm going to say, while it is fairly symmetric for AP Stats. So we've definitely compared the two shapes here by noting that they are not exactly the same shapes here. Okay, next thing we want to address, I'm just going to go in the order of SOCS here, so outliers would be next. And we've already determined that there is in fact an outlier for AP Calculus. So we're going to say AP Calc has one outlier at 3.1. And based on the box plot here, we don't see any outliers, right? An outlier would be indicated with a little dot or a star of some sort. We don't see any outliers for AP Statistics. So I'm going to say while AP Stats has no outliers. All right, so we've taken care of outliers. Up next is the center. Well, we looked at the center for AP Calc, and we decided that we would use the median there. And so the median was 3.9. Well, very clearly, the median is lower for AP Statistics. Even if you compare the means, you'll notice that the mean for AP Calculus is higher than AP Statistics. Now, the important thing here is that we are trying to compare the centers, which does not mean that we need to actually list the values of each one. We have to make some sort of comparative statement between the center of AP Calc and the center of AP Stats. And very clearly, the center is higher for AP Calculus students than for AP Statistics students in these samples. So I'm going to say the center of the distribution for AP Calc is greater than the center for AP Stats. Now notice I didn't even have to indicate what measure of center I was using, which would be true whether I was using the mean or the median. I also haven't indicated the exact values of those centers. What's important here is that we've compared the centers. So I'll tell you this part of the solution right here is an important part of the solution, the fact that we're saying that the center is greater for AP Calculus students. All right, for the spread, we're going to have to do the same thing here, compare the spreads. And we could do it using range or IQR or standard deviation. We might choose IQR because the AP Calculus distribution is skewed to the left. But if you look at all measurements of spread, you're going to see the standard deviation is lower for AP Calculus than it is for AP Statistics. If we calculated the IQRs, it would also be lower for AP Calc, or the ranges, all 3 of those measurements. So very clearly here, we can say that the spread for AP Calc is less than the spread for AP Stats. And I'm going to highlight again the fact that the comparative word is the important word here. So definitely when you're asked to compare the distributions, you want to use less than, greater than, similar to. That's the type of language that we want to see when we're comparing those two distributions. All right, and let's get to the last question here, number 6. Do the data provide convincing evidence that AP Calculus students have a higher GPA than AP Statistics students on average? Now, this certainly sounds like something from much, much later in the course, namely a significance test, right? Anytime you see convincing evidence, you think that you might need a significance test to answer that question. But before we talk about convincing evidence, let's just see, first of all, do we have some evidence that AP Calculus students have a higher GPA? Well, if you look up at the data, the average, which I'm going to call X bar, for the calculus students is 3.805. The average for the statistics students is 3.16. So based on these two samples, we can see that the X bar for the calculus students is in fact greater than the X bar for the stats students. So we certainly do have some evidence that AP Calc has a higher average. But do we have convincing evidence? Maybe the fact that these were both just random samples, because of random variability, we just happen to pick some high GPAs for AP Calculus and some lower GPAs for AP Stats. And it's not actually true when we look at all AP Calc and all AP Stats students. Well, in order to answer that question, we need a significance test. So I'm going to say here for the last question, possibly, right? We do have some evidence. In order to know if we have convincing evidence, we would need to do a significance test. And specifically here, let's think about what test we would need here. Well, are we in the world of means, the world of proportions? Hopefully you said the world of means. Do we have one sample or two samples? Definitely have two samples here. So we are going to need a 2 sample, and this is going to be a t-test for the difference of means, mu1 minus mu2, to find out. Now, if you're interested in knowing how to do that particular significance test, we do have a separate video on YouTube that you can check out for significance test for means. All right, so I think that's it for this particular part of the activity, and we are ready for page 2. So if you want to slide on over. And we've got a little bit different context here to start out. All right, so here's what it says. It says, one of the other questions that university admissions officer asked the AP Calculus and AP Statistics students was their college plans for after high school. The table summarizes their responses. Okay, so I notice here in the table that we've got the course listed on the left. We have our 2 groups, our AP Stats students and our AP Calculus students. And then up here, we are talking about their college plans, which looks like they had 3 choices. They could say none, or community college, or university here. So the first thing I'd like to do is to identify the variable that's being measured here. And you might say course is a variable because there are 2 different possibilities there, but we've really selected samples from 2 different groups there. And this is really the thing that we're asking the sample, right? What are your college plans? So the variable here is going to be college plans. Now let's think just for a second here. Is that variable a quantitative or a categorical variable? Well, college plans has 3 different categories that they could select there, right? This is most definitely categorical variable. Okay, much different than the first page of the activity where we were dealing with quantitative data, which involved numbers. Instead here, we're talking about categories, the category of none, community college, and university. So let's see what the analysis looks like for a categorical variable, which is going to look a bit different than the analysis we did for a quantitative variable. So here we go. Number 1 says calculate the percent of AP Statistics students for each category of the college plans. Okay, we got 3 different categories. So let's start with the category of none. And very important here, we're only looking at the AP Statistics students in order to calculate this percent. So that means that I'm only looking at these values here, that very first row in the table here. So the percent of AP Statistics students that were none, well, that's 2 out of the 10 total, which is 20%. 20% for that first category. Now, the second category is the category of community college. And once again, we are only going to be looking at the first row, which is the AP Statistics students. And for community college, I see 3 out of the 10, which is telling me 30% of AP Stat students plan to go to community college. And then the final category here is that of the university. And once again, only looking at the first row, I have 5 out of my 10, which is going to be 50% of AP Statistics students that plan to go to university. So as a quick check here, we can make sure they add up to 100%. And sure enough, 20 plus 30 plus 50 is going to get us there. So we're all good on that. All right, let's move to number 2, which is now to calculate the percent of AP Calculus students for each category of college plans. So now we are only dealing with the AP Calculus students, which is the second row in this table. And we want to find a percent within each category. So starting with none, I have 1 of my AP Calculus students. That is only 1 out of 20. That is 5% of AP Calculus students that do not have college plans. Move over to the next category of community college. Look up in my table here, and it looks like there are 4 out of the 20, which is going to give me 20%. And then finally, the last column we have is the university. And based on the values here, it looks like 15 out of 20, and that is going to give me 75%. So now we're going to try and take those values and make a graph with them. And specifically, we're going to make a segmented bar graph to display the distribution of college plans. So let's start with the AP Statistics students. And we know, let's see here, 20% of those students said none. So I'm going to make a little bar chart here. And I'm going to try and go up as close as I can to about 20%. And I'm trying to stay consistent with my colors here. We have blue to represent none. And then for community college, we have 30%. So I need to stack 30% on top of 20%, which should take me up to 50%. Those are the students that are planning to go to community college. And that last 50% is going to take me all the way to the top here. 100% is going to be those planning to go to the university. Now that's AP Statistics. Now let's do the same thing for the AP Calculus students. So 5% planning to go or with no college plans, and 20% planning to go to community college. So if I stack 20% on top of this here, it's going to put me at about 25%. So I should be right about here. Doing my best to try and keep this as accurate as possible. And then the remaining 75% plan on going to the university. That should take me right up to the 100%. So there is our segmented bar graph. I will say that you do want to have a key to go along with your segmented bar graph so that the reader knows exactly what each one of those sections represents. And well, we sort of listed it above, but the blue represents no college plans. The red represents community college, and the green represents university. And so there we have a segmented bar graph to show the distribution of the college plans for each one of the groups of students. All right, that leads us to number 4. Is there an association between course and college plans for this sample? Explain. So when we're asking if there's an association, another way of putting that is to say, if we were to know one of the variables, would it help us to predict the other variable? So if you knew a student was AP Stats or AP Calc, would it help you to predict what their college plans are? Well, based on this graph, I would say definitely, because these two distributions do not look the same, right? So we're going to say that the answer here is yes. And the reason is because knowing a student's course, right, or whatever class they're in, so knowing a student's course helps us predict their college plans. Now, we should go into a little more detail here to explain. Specifically, like if I knew they were AP Statistics, I can see, well, when I compare the blue to the blue is much larger for AP Statistics students. So I'm going to say AP Stats students are more likely to have no college plans and the other sort of big difference here is that when you compare the green to the green, the AP Stats students are much less in the green category. So we're going to say, and less likely to be going to university. Than AP Calc students. So we've provided further evidence of why we do in fact think that there is an association between those two variables. Now that takes us to question number 5. What information is missing from the segmented bar graph? Well, here's the thing. If you look at the segmented bar graphs, they show you percents, right? Percents of the total. But what we don't really know is what the total is. And it turns out that these two totals are not the same. We did not have the same number of AP Stats students in our sample as we did AP Calc. And if you recall, the AP Calculus had twice as many in the sample size than AP Statistics. And you don't necessarily see that in the segmented bar graph. Okay, so the thing that we don't see, the information that's missing, is the fact that the AP Calculus sample size is double the AP Stats sample size. Now, we do have a way of fixing that, and is using a new type of graph, which is called the mosaic plot. And essentially, the mosaic plot is the segmented bar graph, but somehow we want to show that there were twice as many AP Calculus students in the sample as AP Statistics. Well, check this out, very easy. If I want it to be twice the size, I'm going to make the width of the bars twice the width of the bars for AP Statistics. So all I'm doing here is I'm doubling up my bars. And now I have what's called a mosaic plot. And from the mosaic plot, you can actually tell the difference in the totals based on the width that you see of the bars. Okay, final question here. Number 6, do the data provide convincing evidence of an association between course and college plans for all AP Stats and AP Calc students? Now, that sort of sounds like a question we've already answered here, right? Number 4, but if you look closely, there's a difference in the wording here. In number 4, we were asked about college plans for this sample or for these two samples, whereas in number 6, we are asked for all AP Stats and AP Calc students, right? So now this is doing some inference. We're taking our sample and trying to make an inference about the population. And sure enough, in number 4, we said there's an association for these two samples. But remember, these are random samples, and there's a lot of variability in the results that you get from a random sample. So maybe the same will not hold true for the whole population. So in order to answer that question, once again, we need a significance test. So I'm going to say, well, possibly, we do have some evidence, but in order to decide if we have convincing evidence, we need a significance test. And let's think about what type of test we need here. Categorical variables instead of quantitative. So that puts us in a whole new bucket of possibilities in terms of inference. And hopefully you'll remember that this would require what's called a chi-squared test. And specifically, this is going to be a chi-square test of homogeneity. Now, quick note here, for the 2020 AP exam this year, you are not required to know the chi-squared test. That was one of the topics that was taken off the AP exam for 2020 only. Okay, so let's see if we can summarize the learning that we had here. So go to the next page where we have our important ideas. And this is where we're going to go back to the 3 learning targets that I started with at the beginning of the lesson. So the first learning target was everything to do with quantitative variables. So let's start there. Okay, the first thing that I want to point out are the types of displays that you can use for quantitative variables. And we saw 2 of them in the activity, right? We definitely had a dot plot, in my opinion, the superior graphical display for quantitative data. And we also saw box plots. But there are a couple others that you should be familiar with. You should know how to interpret a stem plot, as well as histograms. Now, here's the big takeaway for quantitative variables. If you are asked to describe or compare distributions, this is where you're going to want to use SOCS plus context. So a quick reminder of what you need to make sure that you address: the shape of the distribution, whether or not there are outliers, the center of the distribution, and the spread. Let me make a couple of side notes on this one here. For the center, we generally are going to use the mean or the median, depending on the shape of the distribution. If it's skewed, you're going to want to go with the median. If it's fairly symmetric, the mean will be best, or the median actually will be very similar. In terms of spread, we have a few choices here: standard deviation, IQR, and a very basic measure of spread is also the range that you could use. Now, a couple of quick notes. When you're doing this whole SOCS thing, you must always use context. And once you've established context once within a free response question, you don't have to continue to say it over and over again. And then the other thing I'm going to make note of here is when you are asked to compare. So when you are comparing 2 distributions, you want to use terms like less than, greater than, similar to, right? Comparative language, rather than just listing out the center and the variability for each one of the distributions. Okay, let's move to learning target number 2, which had to do with now categorical variables. And let's first talk about the types of displays that you can use for categorical variables. And we saw both of these: the segmented bar graph, and then we actually turned our segmented bar graph into a mosaic plot. Another choice that you might have here is to look at a pie graph or a pie chart. All right, now what should we take away here? Well, I just want to draw a quick picture here of what the segmented bar graph looks like. And a couple of things that hopefully you noticed on the segmented bar graph. First of all, the y-axis is going to be the percent. And I sure hope you noticed that the very top of that segmented bar graph was 100, started at 0, went all the way up to 100, right? And typically you're going to have 2 groups, although you could have more than 2 groups. And you're going to look at the distribution of that categorical variable in that segmented bar graph. So you might have something like that and something like this, and maybe the distributions look different, right? And you would also include some sort of a key. Now that's a segmented bar graph. If you want to turn that into a mosaic plot, you're going to need to scale the widths of the bars. So I'm going to say here, mosaic plots, scale the width of the bars. And let's get to our last learning target, number 3, which very specifically was about the idea of association between two categorical variables. And let's just go with the definition on this one. Association means knowing the value of one variable helps us predict the value of the other variable. And you can really answer that question by looking at the segmented bar graph. If those two distributions are different in any way, then there is an association. If there were no association, then those segmented bar graphs would look identical for each one of the groups. All right, I do have a homework problem for you here, the Check Your Understanding. It is an old AP exam question, 2016, number 1. So if you could try that problem before class tomorrow. Tomorrow, Mr. Brandon Murphy will be with you, and he will be talking to you about normal distribution calculations. And then I will be back on Wednesday to talk with you about two-variable data analysis. So listen, if you got something out of today's lesson, it was helpful to you, please give me a thumbs up there in YouTube. I sure hope you'll be joining my colleague tomorrow, and then I will see you back here on Wednesday.